Hello children, welcome back to the digital class. I hope you are all doing well. So today we are going to learn some interesting topic in mathematics. So let us start our session. So children, today I am going to show you a mathematic show. Let's see. Oh, here comes the magician. The magician invites a gentleman and two kids. Today I am going to perform a mathematic show. Are you ready children? Yes. Let us start. Today I am going to tell you your ages without asking you your exact age. I am going to tell your age. So dear, in today's mathematic show I am going to tell your ages using some mathematical calculations. So let us start. So gentlemen, double your age and add 10 to it. Now can you tell me the number gentlemen? It is 90. Okay, your number is 90. Abracadabra, your age is 40 years. Amazing, you have guessed the age correctly. How could you do that? Now it's your turn children. Now double your age, add 5 to it. And can you tell me the number please? 21 sir. Okay, it's 21. Abracadabra, your age is 8 years. Amazing. How could the magician do this wonderful trick? Children, do you all want to learn this trick? You can learn this trick using simple mathematical calculations. So today, in our topic, Introduction to Algebra, we are going to learn such tricks. So let us start our session. By the end of this session, you will learn patterns making rules, expressions with variables, simple equations, and also solution of an equation. So before that, let us see what is meant by algebra. Take a look at this tree. Yes, you have seen a tree with lot of branches, right children? Yes. A mathematics is also like a tree with different branches. You can see there are a lot of branches in mathematics like geometry, arithmetic, calculus, so on. Now algebra is also one such branch of mathematics. So algebra is a branch of mathematics that deals in representing numbers through variables. Now let us learn about some patterns and how to make rules out of these patterns. Look at this smiley. How many eyes does it have children? You are right, it has 2 eyes. Suppose if I take 2 smileys, now in that case, yes, it has 4 eyes. Now what about 3 smileys children? Yes, it will have 6 eyes. Now take a look at this number of smileys, 4. How many eyes should be there children? That is correct, 8 eyes. Now let us summarize this using a tabular form. So in the tabular form, I am going to take a number of smileys and the number of eyes, that is the total number of eyes, and what are we going to observe from that smileys. Okay children, let us see. So we have seen when there is only one smiley we have 2 eyes, and when there are 2 smileys there are 4 eyes. Similarly 3 and 4 smileys we have 6 and 8 eyes respectively. Suppose if the number of smileys are 5, now can you tell children how many eyes they will have altogether? You are right once again, 10 eyes will be there. Suppose if there are 9 smileys, how many total number of eyes are there children? You are right once again, there are 18 eyes. Now let us observe these things very carefully children. Now I am writing this number of eyes, that is 2, as 2 into 1. Similarly, the number of eyes 4, I am writing it as 2 into 2. Similarly, I write 6 as 2 into 3, 8 as 2 into 4, 10 as 2 into 5, and finally 18 as 2 into 9. But why did we write like this children? Take a close look at this. So 1 is the number of smileys, so here 2 into 1. Here number of smileys are 2, so I wrote 2 into 2. Here number of smileys are 3, so 2 into 3. Like that, the number of smileys are 9 here, then we are writing 2 into 9. So, do you observe any pattern in these children? Yes, we notice that the number of eyes or the total number of eyes I can say is equal to 2 into the number of smileys. This is what we observe, right children. Now, this is called the rule of the pattern. So, this number of eyes equal 2 into number of smileys is the rule of the given pattern, that is the smileys. Okay children. Let us consider the number of smileys as m. Now, in that case, what will be the total number of eyes children? Yes, let us see. So, here we have seen when one smiley is there, 2 into 1, 2 smileys are there, 2 into 2, 3 smileys, 2 into 3, like that we have m smileys. So, what will be the number of eyes children? That is right, 2 into m. Now, what is 2 into m children? 2m. So, we get the number of eyes in m smileys as 2m. Okay children. Now, take a look at the pattern just now we have seen. We got the number of eyes in m smileys as 2m children. Now, this m is called a variable. So, a variable is a quantity that takes different values and it does not have any fixed value, and these variables are represented by any of the letters in English alphabet. You can use M or A, B, P, Q, X, Y, any of the alphabet you can use children. Okay. Now, let us take another example of a pattern. Before that, children, do you know what a square is? That is right. A simple closed figure in which all 4 sides are equal is called as a square. And children, how many matchsticks are required to make a square? So, here is a square with 4 equal sides. Now, let us see how many matchsticks are required to draw this square. Did you notice children? How many matchsticks are required here? You are right, 4 matchsticks are required. Okay children. Now, let us make patterns using these matchsticks. So, for one square we need 4 matchsticks. Suppose if you have 2 squares arranged this way, how many matchsticks you require children? Yes, you require how many children? Here these are 4, 5, 6 and 7. So, you need 7 matchsticks. Similarly, if I have 3 squares arranged in this manner, then how many matchsticks required children? You are right, you require 10 matchsticks. Finally, let us take another pattern, that is with 4 squares. How many matchsticks children? You are right once again, 13 matchsticks are required. Let us observe these patterns now. So, we have already seen for 1, 2, 3 and 4 squares, the number of matchsticks required are 4, 7, 10, 13 respectively. Suppose if we have 5 squares, then how many matchsticks are required children? That is right, we need 16 matchsticks. Let us see how we got that answer 16. So, on observing, I can write this 4 as 3 into 1 plus 1, whereas 7 can be written as 3 into 2 plus 1 and 10 can be written as 3 into 3 plus 1, 13 is written as 3 into 4 plus 1. So, similarly, if you write what is 16 can be written as children? That is right, 3 into 5 plus 1. But why are we writing in this manner children? Let us see. So, if you notice, the number of squares are 1 here. So, we got 3 into 1 and rest 3 and 1 is common everywhere. If you notice, they are same, we are not changing first 3 and the last plus 1. But here in the first one, 1 square into 1, 2 squares into 2, 3 squares into 3, 4 squares into 4. So, 5 squares means into 5. Now, how can you write the rule of this pattern children? Yes, let us consider the number of squares as S. Therefore, number of matchsticks required equal to 3 into the number of squares plus 1. Now, let us substitute the value of number of squares. So, number of matchsticks used is equal to 3 into S plus 1. 3 into S is how much children? 3S. So, we get 3S plus 1. So, this is the required rule children for this pattern. Okay. Now, here children, if you notice this 3S plus 1, this is called as an expression. Okay children. So, 3S plus 1 is called an expression, and in this 3S plus 1, S is called the variable. So, what is this 3s plus 1? We call it as children expression with variable s. Suppose you have 2x plus 3, then it is an expression with variable x. Okay, children. So, let us see what are the uses of these expressions in our daily life situations. So, rupees 10 less than what Ram has. This is the statement. Now, how to represent this statement as an expression? So, let us consider the variable as y. Okay. Why it is y minus 5? Because Ram has 10 rupees less than, okay, rupees 10 less than what Ram has. So, suppose I am considering myself, I have 10 less than Ram. So, it is y minus 10. Okay, children. Now, 9 times p is added to 10. So, here the variable is p and 9 times p is 9p. So, we are adding that 9p to 10. And the next example is Renu's height is 3 feet less than Anu's height. So, let us consider the variable as z. So, here we have to find what, children? Renu's height is 3 feet less than Anu's height. So, what will be the height, children, now? Z minus 3. Okay. So, that is the expression related to this mathematical statement. Now, suppose if the expressions are given, how to write the mathematical statement? So, in x plus 2, variable is x. So, I can write 2 kg more than Anu's weight, or you can write in another way also. I have 2 rupees more than some x, right. The next is 3p minus 8. The variable is p, 3p stands for 3 times p and I am subtracting 8 from it. So, 8 subtracted from 3 times p. Let us take one more example, 2n plus 11. So, here what is the variable, children? N. So, here we have 2n, 2n means 2 times n and we are adding 11. So, what do we write, children? Yes, 11 added to 2 times n, or you can write 11 added to twice n, both are correct. So, children, till now we have learned some patterns and how to frame the rules for the patterns. We learned what a variable is and also an expression. Now, let us learn more about simple equations. Let us see what a simple equation is. So, take a look at the example, children, what we have already done, that is about smileys and the number of eyes. We have already got total number of eyes for m smileys as 2m. Now, suppose there are 50 eyes altogether, then how many smileys are there? Let us see. So, here 50 smileys, that means 2m should be equal to 50. Now, this 2m equal to 50 is called a simple equation. So, notice that, children, here in this equation, if you notice, there is an equal to sign here. This is equality sign. Okay, children. Now, whenever this equality is there between two terms or two expressions in between them, then only we call it as an equation. Okay. So, if you notice, in 2m equal to 50, 2m is called the left hand side of the equation, or in short we call it as LHS, whereas the number which is after the equal to sign, that is 50, is called the right hand side of the equation, or in short we write it as RHS. So, children, a simple equation has, or an equation has, a LHS and a RHS, and in between these two we have an equal to sign. Okay, children. Now, let us see what is meant by an equation. So, an equation is a condition on a variable for which the values of the variables are limited to a specific thing. That means, we are going to find the value of this variable based on a given condition. Okay, children. Like here 2m equal to 50. So, that is the condition given, that is 2m is 50. Now, from that we are going to calculate the value of m. Okay, children. Now, let us come back to our mathematic trick, how the magician has done the trick. Let us see. Let us assume the age of the child as x years. Then the magician told to double the age of the child. So, double the age means 2 times x. So, we get 2x years. Then he said add 5 to its age, that is to 2x we are going to add 5. So, what do we get, children? 2x plus 5 years. So, we got an expression, and then he asked What is the number they got? So, the child replied 21. That means, this expression 2x plus 5 is equal to 21. So, what did we get, children? Yes, we got 2x plus 5 equal to 21, which is a simple equation. Okay, children. Now, let us find the value of this variable x. So, for that I am going to take a tabular form in which I am first writing the value of the variable x, then I am going to calculate the value of LHS and also the value of RHS, and I am going to check whether both LHS and RHS are equal or not. Let us start. So, the value of x I am substituting it as 1. So, what do you get, children? 2 into 1 plus 5. Why 2 into 1? Because in this 2 into 1. So, we are substituting in place of x 1. Okay, 2 into 1 plus 5. How much did you get, children? 7. But what is the value of RHS? 21. Are they equal, children? 7 and 21? No. So, both are not equal. So, let us go for the next number, that is 2. Now, again substitute 2. So, we get 2 into 2 plus 5, which is 9. RHS is 21. Again we got both LHS not equal to RHS. Let us go for the next number 3, children. Yes, we got 11 on substituting it, and RHS value is 21. Again both are not equal. Let us substitute 4 and check. Yes, LHS 13, RHS 21. Again not equal. Go for the next one, 5. So, 2 into 5 plus 5, which is 15. RHS is 21. Again both are not equal. We substitute even 6 also, and we see that LHS and RHS are not equal. Let us go for 7 now. So, 2 into 7 plus 5 is 19. The value of RHS is 21. Again both are not equal. Let us substitute 8, children, now. So, we get 2 into 8 plus 5, which is 16 plus 5 21, and RHS value is also 21. Now, in this case we got both LHS and RHS values are equal. So, for what value of x you got, children? Yes, for x equal to 8 we got both LHS and RHS values as equal. Now, this x equal to 8 is called the solution or the root of the equation. So, which equation, children, here? Yes, 2x plus 5 equal to 21. Now, for this x equal to 8 is the solution. What do you mean by that? If we substitute the value of x as 8, children, now we get the value of LHS and RHS as same, and you substitute any other value other than 8, you will never get LHS equal to RHS. So, that is why this x equal to 8 is called the solution or the root of the equation. Okay, children. Now, how do we define this? Yes, the solution is nothing but the value of the variable for which both LHS and RHS are equal, and this method of solving the equations we call it as trial and error method. So, children, till now we have seen the different patterns, and also we have seen the rules, making the rules of the pattern. Then we learnt about variables, expressions, equations, and also we have solved the equation using trial and error method. Now, to understand these concepts much more clearly, let us take some examples. Let us start with our first example. Find the rule which gives the number of matchsticks required to make the following matchstick patterns. The first one is Z and the second one is L. Let us start with the first one, pattern of Z. So, how many matchsticks are required, children, to make Z? Right, we need 3 matchsticks. Now, similarly, to make 2 Zs, how many are required, children? That is right, we require 6. So, similarly, we will find out for 3 there are 9 matchsticks required, and for 4 we require 12 matchsticks. Let us summarize this using a tabular form. So, we are taking number of Zs, number of matchsticks, and also what we are going to observe from those two. So, when we have 1 Z, number of matchsticks are 3, when 2 Zs, number of matchsticks are 6, 3 Zs and 4 Zs, we have 9 and 12 respectively. Now, for 5 Zs, how many matchsticks are required, children? You are right, 15. For 6, yes, 18. Now, let us see how we got 5 and 6 values. So, I am writing this 3 as 3 into 1. Okay, children, this 3, that is the number of matchsticks, I am writing it as 3 into 1. Then the next one 6 I am writing it as 3 into 2, and 9 3 into 3, 12 3 into 4, 15 3 into 5, 18 3 into 6. So why are we writing this way? Because in the first case, that is when the number of matchsticks are 3, how many z's are there? 1. So 1. Here number of matchsticks are 2, so I am writing it as 2. Number of matchsticks are 3, so 3. So when we have 6, so I am writing into 6. Then what can we conclude from this, children? Yes, the number of matchsticks required are 3 into number of z's. Now let us assume the number of z's as m, children, where m is a variable. So therefore number of matchsticks required is equal to how much? 3 times m. What is 3 times m, children? 3m. So this is the rule for the first pattern z. Okay, children. Now using this you can find any number of matchsticks for any number of z's. Okay. Now let us go for the next pattern, that is letter L. So how many matchsticks required, children, to make this L? Yes, 2 matchsticks are required. For 2 L's you need 4 matchsticks, right? So let us see, for 3 and 4 how many you require? Yes, for 3 you require 6, for 4 you require 8. Now again we will summarize the same thing using the tabular form. So number of L's and number of matchsticks and observation. So for 5 you need how many, children? Yes, 10 matchsticks, and for 6 you need 12 matchsticks. Let us see the observation. So again I am writing this 2 as 2 into 1, and 4 as 2 into 2, 6 as 2 into 3, and 8 as 2 into 4, and 10 as 2 into 5, finally 12 as 2 into 6. Because see, here 1 and here also we have 1. Here number of L's as 2, so we have 2. Number of L's is 3, 3. So on. So what do you notice from this, children? Yes, number of matchsticks required is nothing but 2 times number of letters L, right? Suppose if I am going to assume the number of L's be n, here n is a variable, then what will be the number of matchsticks required, children? Yes, 2 times n. So 2 times n is 2n. I hope you understood this problem clearly, children. Let us move on to our next problem. Arun and Varun are brothers. Arun is 5 years younger to Varun. Write Arun's age in terms of Varun's age. Let us start with the solution. So given Arun is younger to Varun by 5 years. Okay. So let us see the tabular form. Suppose if Varun's age is 8, what is Arun's age, children? 8 minus 5, that is equal to 3, because Arun is younger. Younger means his age will be less than Varun. Suppose if Varun is 10, what is the age of Arun, children? Yes, 10 minus 5, which is equal to 5. If Varun's age is 12 years, then what is Arun's age, children? Yes, you are right once again. 12 minus 5, that is 7. Now I am going to assume the age of Varun as some p years, where p is a variable. Now what will be Arun's age, children? You are right once again. Arun's age will be p minus 5 years. Let us start, sorry I repeat once again. Let us move on to our next problem. Write the expression for the following statements. 2/3 the product of numbers p and q. 20 subtracted from 3 times the sum of a and b. Let us start with the solution. So your given numbers are p and q. And what is product of p and q, children? Yes, p into q. I can write it as pq. And also it is given that 2/3 the product of numbers. So 2/3 means 2 by 3 product, that is into pq. So we get 2 by 3 pq. So this is our first bit. Let us move on to our next bit, children. That is 20 subtracted from 3 times the sum of a and b. So here the numbers are a and b, and sum of a and b means a plus b. So a plus b remains same. Okay, you cannot write it as ab, because only when we have product, that is into a into b will be ab. Okay, children. Now 3 times the sum. So 3 times means 3 into a plus b. So we got 3 within brackets a plus b. 20 subtracted from this 3 times the sum, that is 3 into a plus b minus 20. So this is the expression obtained. Let us move on to our next problem. Write 2 statements for each of the following expressions. Okay, children. So given expression is 3z minus 15. So I can write this as 15 subtracted from 3 times z. Let us move on to a second bit. What is the given expression? 2y by 5. So, what is the statement, children? 2y. 2y means 2 times y. So, 2 times y divided by 5. So, this is the mathematical statement. So, let us move on to our next question. Solve the following equations by trial and error method. Let us see the first one, that is x plus 4 equal to 9. So, we are going to use a tabular form where we take value of x, value of LHS, value of RHS, and also we are going to check whether LHS is equal to RHS or not. So, what we are going to do, children, here we will start with x equal to 1. So, x is 1. So, in LHS we have x plus 1. So, in place of x substitute 1. So, we get 1 plus 4 equal to 5. What is RHS, children? 9. So, 5 and 9 both are different, that means LHS not equal to RHS. Now, we will substitute next number, that is 2. So, in place of x we write 2. So, 2 plus 4 is 6 and RHS is 9. Again both are not equal. So, we go for next number, that is 3. 3 plus 4 is 7. Again RHS is 9 and both are not equal. Now, go for the next number, children, that is 4. So, 4 plus 4 is how much? 8 and RHS value is 9. Again 8 and 9 both are different. So, both are not equal, that is LHS not equal to RHS. Now, substitute 5, children. Yes. So, 5 plus 4 is 9 and RHS is also 9. So, here both the values are same, that means LHS is equal to RHS. Now, notice, children, for what value of x both LHS RHS are equal? Yes. For x equal to 5 both LHS and RHS are equal. So, we call phi as the solution of the equation x plus 4 equal to 9. Let us move on to a second bit, that is 3q equal to 18. So, same tabular form, children, again, and again we will start with the first value of q, that is 1. Now, substitute in LHS 3q, that means 3 into 1. So, we get how much, children? 3 and RHS is 18 and both are different. So, not equal. Now, let us substitute q equal to 2. 3 into 2 6 and RHS 18, again both not equal. Substitute q is 3. 3 into 3 9, RHS is 18, again not equal. Now, substitute 4, we get 3 into 4, that is 12 and the value of RHS is 18. Again we got LHS not equal to RHS. Now, let us substitute 5. 3 into 5 how much, children? 15 and the RHS is 18. Again 15 18 both are not same. So, LHS not equal to RHS. Let us substitute 6, children, now. So, 3 into 6 is 18 and RHS is also 18. That means both LHS value and RHS value are equal. Now, again, children, for what value of q both are equal? Yes, for q equal to 6 both the LHS and RHS values are equal. Now, I can say q equal to 6 is the solution of 3q equal to 18. So, children, we have learnt the concept of variables, expressions, equations and solving the equation using trial and error method, and we have seen some examples also to understand the concepts in much better way. Now, before we end our session, let us quickly recap what we have learnt. A branch of mathematics that deals with representing numbers through variables is called algebra, and variables can take different values and have no fixed values, and of course, there are some numbers. So, English alphabet like A, B or X, Y or all these things are used to represent a variable. The value of expression to the left of the equality sign is called left hand side or simply LHS of the equation, and the value on the right side of the equal to sign is called right hand side or RHS of the equation. Solution or root of an equation is the value of the variable for which LHS and RHS values are equal. So, children, I want you to do some problems related to the concept that we have learned in our session. So, let us quickly go through those problems. You solve these problems and show it to your teacher. Okay, children. So, children, with this we come to the end of our session. We will meet in our next digital class. Till then, Goodbye and take care.